Hello, my name is Matthew Livengood. This is my Fluent project number 2. I'm just going to be demonstrating the 30-degree case in this. So let's just get started with that. Okay. I'm just following Dr. Osbey's method of creating the structure here. Okay. So let's just double check. This should be 50. So both of these are 50, I believe. Yep. Okay. Perfect. All right. So there's our surface and our plate in there. So let's do our meshing. Okay. So first of all, so this is very rough, so we're just going to change the element size here. And we're just going to add a refinement of 3 and apply it. Okay, let's just see how many. All right, that'll work. So let's go ahead and just name everything. This is symmetry. Symmetry. Inlet. Outlet. And let's just go ahead and zoom in on here so you can see it better. I'll call this wall top. Wall bottom. This will be wall front and wall back. Okay. All right. So we're just going to change the viscosity K epsilon. Just change the velocity here. Everything else is wall, symmetry, pressure outlet, and the interior. So we need to change our reference values. Velocity is 5, our length is 0.5, and our area is also going to be 0.5. So let's initialize. And run it. Should be converging soon. Yeah, it looks like it's taking that trend. Something that I've found is having a little bit coarser mesh helps this whole graph go a lot faster instead of having a very fine mesh with a ton of nodes. Yep. And let's just show the forces here. So as we see, these are our forces. The pressure force acting on the wall is around 6.2 newtons, and the viscous force is 0.04. It's very small. So that tells us that most of the force acting on the wall is because of the pressure of the flow hitting it. And you'll see that in the next part, there'll be a big clump of pressure on the top corner of the wall. So let's just open up our simulation part. Okay, I'll start with the contours. And I'll show velocity first. So let's just take a look here. So as you can see, just looking at this, as the flow goes around the plate, these areas outside of the boundary layer here, the velocity is actually higher than the original 5 meters per second velocity. But as we get into the boundary layer, it starts to gradually slow down until it gets to 0 and nearly 0. And then as we see, it kind of resumes its original 5 meter per second flow after a while, once you get out of this turbulent region here. So pressure. So like I was saying, we have a very high pressure concentrated right here on this top corner of the wall. And that's where most of the force on this plate is coming from. And then back here is it's a large area of very, very low pressure. So this brings me back to kind of the question that we were asked on one of the quizzes or on one of the exercise sets about why golf balls have dimples. And because that low pressure zone behind the golf ball slows it down in the air, it pulls on it. So if this was moving through the air, this is the type of low pressure area that we would see behind it. And I'll just show the turbulence just for good measure. So yeah, here we go. Like I was saying, this area back here is very turbulent. And if this was longer, we'd be able to see that the turbulence slowly starts to dissipate and eventually goes back to nothing. But as it flows over, this air all mixes back here. The flow reverses and starts flowing in the opposite direction. So it's all this churning is causing it to be a very turbulent zone. And I will show that with vectors here. So and let me just get rid of this contour. So like I was saying, we have, if we zoom in here to the front, you can see as this is flowing to the right in the positive x direction, oops, in the positive x direction, these flows in here, they're turning around. As you can see, this one turns this way, this one turns this way, and they flow back into each other. So this is slowing down, slowing down, slowing down, and then it gets to this point here where it either splits and goes off this way, or it splits and turns and comes back towards the plate. So this is the turbulent area that I was talking about. See all this turning here. And as you see, there's flow separation right along the corner of the plate on the top and the bottom. So whereas this flow is going this way, this flow is going this way, and vice versa. This is going this way, and then this is going in the opposite direction, just because this whole back area is such low pressure, and it's mixing all the air, and it's moving in all kinds of different directions. So I believe that's all for this case. I'll have more detailed explanations of the other ones in my little report, but I just wanted to show this one because I got good results on this earlier, and it's easier to interpret than some of the other ones. So yeah, thank you.